Okay, so I dug this program out of some stuff I wrote a couple of years ago, so this will be interesting to see how lost we can get. This program is supposed to draw the Mandelbrot set. And so what this thing needs is an image processing library in order to fiddle with an image, right? Does that kind of make sense? So that's what this first line is doing. This is importing an image library from a module called pill, which is why you might want to have Anaconda and stuff. This next bit sets the drawing area in the complex plane. It doesn't super matter whether you know what the complex plane is or not, just so long as you trust me that that's a drawing area. Right? So like this is an x coordinate, a y coordinate, or sorry, an x minimum, a y, x minimum, an x maximum, a y minimum, and a y maximum. Right? And then I'm setting a number of iterations, which I'm going to say is 512. I'm going to set an image size. That's going to be the size of the image that we produce. Then this is going to make what? What do you guys think? Image equals image dot new parentheses with stuff in there does. Definitely. That makes a new image object, right? That's in some red, green, blue mode. That's the size you set to make it. Okay? And apparently the way that image thing works is it takes a mode and then also a size in parentheses. It's a little funky, but whatever. Okay, and then, let's see, I have a bunch of commented out stuff. I'm going to loop through the Y things. Right? And then we're going to do some calculation which involves, like, don't sweat what this calculation is right now. What does that involve, at least? Yeah, should be essentially some algebra, right? Like, this is, take the y you're at, right? That's this y. Adjust by some kind of thing involving the y max, the y min, and the image size. Like, just trust me, that's a reasonable formula right now. Yeah, so there is kind of a slope thing here. This is how many complex bits there are per pixel. Right? And then adding where you started. So yeah, you could think about this as a line. It really is not. And then here we have progress is going to be measured by some formula, whatever. Then we're going to print percent completed and a progress variable, right? And I have this note here. For some reason I don't understand. These three things are different. These look like they should be three different ways to print the same piece of information. Right? So percent D tags a spot that you're going to put in a number. Right? And then it says, and then put in this number where you said percent D. And then percent F says I'm going to put in a float. Right? But that number should be a float. Because I took a float, made an integer out of it, and then divided by 10. The result of that should be a float already. Right? You would think. Okay, and then this other one, I literally put in the formula for the progress variable here. Right? Oh, and I guess I should try the other one, but we'll fiddle with that later. At any rate, this should basically tell you how far through compiling this thing you are. And the reason you might care is when you push go on one of these big iteration programs, if you set these things, right, your image size and your maximum number of iterates, if you set those to be extremely high, this can take a really long time. And it would be nice to know that the code is doing something. right? Because when you hit run, if it just sits there, you're like, is it going to output a file? I don't know. Did it fall into an infinite loop? Could be. Like, I don't know. So I want to know that it's doing something and that it's getting towards somewhere. And then, so I'm still looping through the y's, right? So like I've set a y, I turned it into a complex number, and now in there I'm going to loop through the x's. Right, so we're going to go start on the first line, we're going to go through all the x's first, and then we're going to go to the second line, and we're going to go through all the x's there, and then we're going to go to the third line, and we're going to go all the way across, and then we're going to go to the fourth line, and we'll go all the way across. You guys cool with that? Yeah. Yeah. We're going to iterate on every single pixel in this image. We're going to do something with it. And what we're going to do is we're going to calculate the y value and the x value. And then we're going to stick the two together and make a complex number. You guys know what a complex number is? That would be a real number plus some real number times the square root of -1. Don't sweat this. For right now, all you need to know is that it's a thing. Some math shit. We're going to set the initial value. We're going to set z as 0. And then we're going to for loop again. Right? So this is 3 for loops deep here. And we're going to go up to the maximum number of iterates, right? So we're going to go up to 511 in this case. Right? And we're going to do, or 512. And then we're going to do, if the absolute value of z gets bigger than 2, stop. And otherwise do z equals z squared plus c. You guys with me on that? So we're going to start at 0. Right, so we're going to get 0 squared plus c is c, yep. And then we're going to set z equal to that. And then we're going to do it again if that's not bigger than 2. So we're going to square c and add it to c. And we'll call that z again. And then we'll square that number and add it to c and call that z again. And then we'll square that number and add it to c and call that z again until we either get to 2 or until we hit the maximum number of iterates. Guys cool with that? What's that? Yeah, so until we hit absolute value of 2 means it could be 2 in any direction. And we're talking about a plane here because the complex numbers are a plane. So if it gets past 2 in size, we'll stop. And then we're going to turn the result of iterating, right? So turn the number of iterates, which is going to either be the maximum if it just churns around, or it's going to be however many iterates it took before it popped past 2. You guys with me on that? And then we're going to make that number into a color by doing some modulo arithmetic. Like, just trust me, this makes the number of iterates into a color. And then, what's this line do? That's a line we should be able to understand. First, what thing is it manipulating? Yeah, so that's a method, right, put pixel, that we're running on the image object.
And it's choosing the pixel that we're...
Yep, so it's putting the pixel that we're talking about, right? And it's setting it equal to some red, green, blue value. Like, the way Python handles red, green, blues is a little funky. Normally, I would expect a... Yeah, so the fact that this number is giant makes it seem like it would be really mega blue, right? But, sorry, that's not how this works. Yeah, there's a bunch of different color modes, and there's a bunch of ways to get color modes, right? Like, really, the red, green, blue one that we usually do is not the only method to get color. This one happens to get color by doing some math to it. Don't sweat it. It just makes a color. You put blue in where blue goes, and green in where green goes, and red in where red goes. And that's, you'll notice they're backwards, right? That's red. And then red goes from 0 to 255, right? So then green starts at 256 and goes in the next chunk. And that'll go from 255 times, so from 0 times 256 is 0, right? Up to 255 times 256, which is this number here. Give or take.
Well, that's actually exactly 256 squared.
Oh, this is 256 squared. Oh, of course it is. Because 255 should fit in here. Right. So this should be 256 squared. And then B will range between 0 and 255. So this whole thing will be a number between 0 and 256 cubed. Maybe minus 1.
256 cubed minus 1. So.
Okay, cool. Goodsies. Alright, whatever. Like, color mode, it puts a color where a pixel is. Right? And then this thing saves the result as a PNG file. Right? So that's a string that tells you where to put the silly thing and a file type that you're going to save it as. If you name it .jpeg and then save it as PNG mode, what's it going to do? It's just not going to open. It might yell at you, but probably it's just not going to open. You guys cool with this? At least vaguely? Okay, so let me run this thing because it'll be fun. Why am I in that one?
Why are you there?
I have no idea. Oops. Shift right click to open a PowerShell window. PowerShell. Python. Oops. Mandelbrot.py. Percent completed. Scrolling past quite happily. Yeah, interestingly, the rate at which the progress bar is progressing is not totally uniform, because there are some spots in the Mandelbrot set that are more interesting than others. So we'll give this a second. I'm glad I set this only to 1024 by 1024. If you set this to 2048 by 2048, how much longer would you expect it to take? So you doubled the size, right? So if you envision you have a square like this, right? And then you double the size, it's going to be like this by like that. It'll be 4 times. You guys see that? If you triple it, you'll get 9 times. So it goes up as the square does. And then if you increase the number of iterates, things are slightly weirder. So where should I look for the result? That should have been saved as mandel.png, which is this cool fractal thing. And the reason that it takes longer when it gets to certain places, right, is like up here, when you do this line, right? Remember, I'm doing the y's first and then the x's. So when I do the y's in this line, they take like 3 iterates to escape. Most of them. Like these ones are taking 2, these ones are taking 3, these ones are taking 1. How do I know those are the different numbers of iterates? The different colors? That was in that how do you make a color, right? So you turn the number of iterates to escape into a color. We're doing that with modulo arithmetic. So it's going to change every time. So every time there's one more iterate, this I mod 4, I mod 8, and I mod 16, they're all going to be different, and so it'll give you a kind of an obviously different color. You guys cool with that? The multiplication factors are also making things much different, right? Okay, so that's in here, right? Like this line here takes at most 3 iterates. So it goes through the 1024 pixels in that line, and it does that inside for loop only maybe 3 times each for each of those pixels, right? So it only has to loop through that inside for loop like a couple of thousand times. You guys see that? Okay, but when you go through this one right here, how many times is that going to loop through? Yeah, some of them are chill. Like these couple, like stuff out here, right? Those only take 1 or 2 iterates. But stuff in here, yeah, that might be hitting the max ints. The white ones are actually hitting the max ints for sure. You guys see that? And that's because 512 mod all those things is 0. 512 mod 4, mod 8, and mod 16 is 0. So I'm getting 0, 0, 0 out of this. You guys cool with this? Questions, things? Okay, cool. So, let's explore this funny thing about printing.